Okay. Hey folks, this is the Kubernetes SIG cluster lifecycle cluster API office hours on the 2nd of February. We're abiding to the CNCF code of conduct, so please be nice to each other. Please use the raise hands feature when you want to say something. Yeah, if you have anything you want to talk about, feel free to add a new topic here. If you don't have access, you can join the SIG cluster lifecycle Google group, which is somewhere up here. Yeah, and that should be it. So let's start. So first point, open proposal readouts. Does anyone want to talk about one of the currently open proposals? Okay. Then next up, new attendees. Is anyone new or maybe not so new and wants to introduce themselves? Feel free to just unmute yourself and speak.
Hey, hello. I'm new, Guillermo. Work for AWS, specifically in EKS Anywhere. Yeah, so nice to meet you all.
Welcome. And as you also have a topic in a few minutes. Perfect. Okay, so then let's start with discussion topics. So first of all, I called it upcoming and recent releases. Fabrizio, just expand on whatever I'm saying if I miss something. So the 1.1 release is planned for right after that meeting. And we had a first round of patch releases yesterday. But this morning we found a new issue. And the root cause was that the cert manager repository was moved from the chat stack organization to a cert manager. And ClusterCuddle has the location hard-coded. So essentially all old versions of ClusterCuddle were failing now because they weren't able to download the cert manager. Affected are everything above 0.4. And Fabrizio just released this afternoon fixed versions of 0.4 and 1.0. And the upcoming 1.1 will also include that fix. So for all providers which are trying to, to capture 1.1, that release should fix it again. Anything else? I'm not sure. Okay, looks okay. Yeah, so that should be it. If there are any questions, please just ask. Or raise hand. Okay, perfect. Then Yuvraj.
Stefan,
yeah.
Only a quick shout out to you, Yuvraj Kilian, that jumped in, helped in fixing the self-managed issue in 2 hours, basically.
Thanks. Okay, next up, Yuvraj.
So with KubeCon EU coming up, I wanted to check and see if there's anyone who would be willing to co-present the deep dive, the cluster API deep dive session. And if so, please do reach out, maybe ping in Slack, and we can coordinate from there. Yeah, that's all.
Okay, perfect. Thank you. Then Guillermo.
Yeah, so this is my first time presenting a proposal here. I'm not sure what is the right process here. Like, do we give folks a few minutes to read it? Do I go over the document real quick, or how do I do this?
Good question. I would propose maybe something like giving a rough overview of the proposal and probably then some kind of async review first. I'm not sure. Some other regular hosts here differing. Okay, sounds okay. So I think I can give you rights to present, or I can just open the proposal for you. Up to you.
Yeah, if you don't mind opening it, that would be great.
Yep, no problem.
Yeah, I just realized that Google Docs doesn't understand Markdown. So if you'll prefer, I can just convert this and then paste the right format later, but they should be enough to go over it. Quick summary. So this is just a very simple extension on how cluster resource sets work. It's just adding a new mode. This mode and how it works, it was kind of already mentioned in the original proposal for cluster resource sets. It was like left out of the scope, but it was mentioned mostly how it should work. And if you look at implementation, it's like very clear that it was aimed to something like this. So the idea is there will be a new mode called reconcile. It will just check the hash of the object definitions that we are already storing in the cluster resource binding set. And then if the hash has changed, then we just reapply all those resources in the targeted clusters. There are some clarifications about drift and detecting drift between the cluster resource, the resource definitions in the management cluster and the actual objects in the target workload clusters. This doc on purpose leave those unaddressed, even though it comments some possible solutions. More than happy to expand this if we want to cover those in this mode, but in my opinion, this is the simplest approach that solves the problem. So I just started with that, and I will be more than happy to hear any feedback from you guys.
Yeah. Any comments already? I assume most will be async after folks read the document. Yeah, Fabrizio.
First of all, thank you for this proposal. Second, maybe it's part of the drift discussion, but what happens if something gets deleted from the resource that I'm applying?
Sorry,
so
what is the question? I didn't quite get that.
We make an example. I have a cluster resource set that is applying that links to a secret. Inside the secret, I have I don't know, a config map and a pod. Then I go and I update the secret, removing the config map. Does the reapply detect that something went away and deleted?
Good question. So for deletions specifically, this doesn't address that. It's also called in some of the classification paragraphs. It will detect that there is a change in the secret, which is where the resources are defined, and it will reapply all the resources defined in that secret, but it won't delete the original, let's say that you remove the config map, right? It won't delete the config map from the clusters. It will just reapply all the resources that are defined in that secret. And if those haven't changed, then the end results is you end up with the same objects, but it won't delete it. So yeah, deletions are also not included in this design. They're called out because they won't work, but they're not included in the design.
Thank you. I will have a look at the doc. Thank you for writing again.
For sure.
Yeah, thanks. We had, I would say, quite a few requests in the past and a few duplicate tickets about that mode. So it's nice to see it addressed. Okay. Any other questions? I'm pretty sure we'll get back to it pretty soon in the next meeting. Okay, good. Then Jurash, you have a demo. So, and I think that's the point where I have to figure out how to give you rights. Make host or co-host?
Yes.
Okay, I just give you host. That should be enough.
Okay, cool.
Okay, so stop sharing and then you should be able to share.
Sure.
I probably should have given you co-host because now I'm not host anymore, but I get it back.
Yeah, no problem. Can everyone see my screen and hear me properly? Okay, cool.
I can see you.
Okay, awesome. So in this demo, we're going to talk about a new command in clusterctl called a new alpha command in clusterctl called Topology Plan. With cluster class in its current state, the goal behind this new command is to help users to adopt cluster class, improve the usability of cluster class, and basically give more insights into how cluster class is actually working underneath the scenes and how the topology controller operates on certain inputs that the user wants to play with. right? So there are many use cases for this particular command. We'll be taking a look at a few of them in this demo. So first, let's imagine I am a user who is designing my own cluster class, right? And I want to see how this new cluster class that I'm designing will turn out when a cluster uses that particular cluster class, right? So let's take a look at that, for example. So I have two files called new class and new cluster, and these have the definitions for the cluster class that I'm writing and an example cluster that's using that particular cluster class. So let's just see how we can use this command for a user to figure out what kind of underlying objects will the topology controller create if the user uses this particular class. So cluster cuddle, alpha, topology plan, and then design. Yeah. So I'm passing in my class definition. I'm passing in a cluster definition, which is using this particular class that I'm designing, and I'm specifying an output folder. We'll look at why we need to specify an output folder in just a minute, but yeah, let me run this. So let's take a look at the output. So it says this changes, this inputs that we are applying will touch something called a new class, is acting on a new class, is acting on something called a new cluster, and applying these two files on a real cluster would result in the following set, will result in the following change summary, right? So it means it's going to create all of these objects as specified here, and it's going to modify the cluster object. So it's going to create doc cluster, it's going to create the KCP object, the machine deployment object, and so on. What we would expect the topology controller would do when creating a new cluster with a cluster class. And to get a better insight into the structure of the objects, because I am a user who is designing my own cluster class, I want to see how these objects turned out. We actually write, this command actually writes the outputs, writes the objects onto disk into the following paths. Both of them are written into the output path as passed into the initial command. So we can take a look at that. So it creates two folders called created and modified. So under created, it stores the YAML objects of the final objects that were created as a result of the reconciliation. And for modified objects, it gives us the original, it gives us the modified, basically the final state. It gives us a JSON patch between the two, and it also gives us a diff between the two. So this gives a user, this gives any user the insight on, okay, how particular things are working or how particular inputs will modify the state of my cluster and so on. Now, let's shift gears and take a look at another use case. Let's say I already have a cluster and a cluster class installed on my management cluster, and now I want to change the topology of this particular cluster, and I want to see how that would work, right? So let's take a look at that. Cluster, cuddle, alpha, topology plan, modify, topology. Oops. So I already have a cluster called example cluster installed, and now I'm trying to modify that example cluster with some changes, and I want to see how that would affect the underlying objects within my management cluster. So if I run that, it tells me that, okay, if we apply this particular changes, it's going to change the KCP object and it's going to delete one of the machine deployments. And we can go into the modified folder and then see what are the changes it's doing onto that KCP object and then gather an insight. Now, let's say instead of modifying the topology, I try to modify the cluster class itself, right? So let's take a look at that. Cluster cuddle, alpha, topology, plan, mindset, class. Okay, so I have something called a shared class already installed on my management cluster, and now I'm trying to apply a change to that shared class, and I want to see how that would affect the state of my clusters, right? So if I run this, now this output is interesting. It tells us, okay, applying this change would modify or would affect the shared class, and it would also affect the following clusters. So here we see that modifying that one particular class would affect multiple clusters, and it just lists us all those clusters. And in this case, since there are multiple clusters, it doesn't give us like a detailed output of what changes on each cluster. And we can force it to do that by passing in the cluster parameter and then asking it to specify, okay, give me the detailed output of one particular cluster, let's say the first cluster. And then it would tell us, okay, applying this changes on cluster class would affect the first cluster in the following way. Basically, it would change the KCP object, and we can go and take a look at that modified object to see what actually changes. Now, again, let's move on to another use case. So technically, the users can modify the cluster class and then basically affect multiple clusters. But Cluster API recommends that users instead follow the operation practice of rebasing clusters. What that means is, if I am a user and if I want to change the cluster class, I should instead create a copy of the cluster class with the changes I care about, and then rebase my cluster to the target cluster, rebase the cluster that I want to the target cluster. And let's take a look at and see how this command can help us in figuring out if a rebase is going to work or not, right? So cluster cuttle, alpha, topology plan, -f, rebase. So I have a cluster called target cluster that's already installed, and I have the from cluster that it already is working with, and I have a to cluster that it's trying to rebase to. And I'm applying the change where the cluster is now changing the cluster class from the from class to the to class. So if I run that, it'll tell me, okay, so none of the cluster class will get affected, but your target cluster will get affected, and it'll get affected with these changes. So the target cluster is going to have all of these changes. But this command also helps us in identifying if a rebase operation is dangerous or if it's going to fail certain things, right? So let's say I'm trying to rebase the cluster to a cluster class that is not compatible with its existing cluster. So if I try to do that, it shows us that the rebase operation would have certain negative effects on it. And in this example, it's basically saying that the cluster that we already have is using a machine and in the cluster that we already have, there is a machine deployment that's using something called a default worker machine deployment class. And this default worker machine deployment class doesn't exist in the new target class, the bad class. And therefore, this warns us and lets us know, okay, so the rebase operation would fail if we move our cluster from our existing cluster class to a target cluster class. There are many other use cases for this command. So for example, we can also imagine, what if I change a particular template involved, like a machine template or a KCP template? Like we can figure out, okay, what all cluster classes will this template affect? What all clusters will this template affect? And so on. And this can also be used in cases where, let's say I'm trying to use patches and I want to iterate on patches and see how patches are going to affect my cluster class, or how patches are going to affect my cluster, and how can I consume them and quickly iterate and update my patches to see that it works as I would want them to. And many other use cases. There is a documentation for how to use this particular command within our CAPI book right now. It's in the main branch. So please go ahead and try and use it, and all feedback is welcome. And that is all for this presentation, for this short demo. I'm happy to take any questions if there are any. For no changes, would the output folder be empty? Yeah, if there are no changes, the output folder will be empty. If nothing's created or if nothing's modified, the output folder will just remain empty. Yeah, Fabrizio, go ahead.
Yeah, first of all, thanks. I think that this command is super powerful. It is the first time that we kind of expose, we make it visible what happens by a reconciler. So it is super powerful. I encourage people that are starting with cluster class. Now there is documentation about writing cluster class or changing cluster class, like stuff like that, to go and basically play with the the topology plan command, because they will basically understand what will be the effect of their change without trying them live in cluster. So this is super powerful. We we also try to explain all of this in the documentation, you already saw, but there is really a lot. So we are really looking forward for feedback, how to improve documentation, how to make things more clear for the newcomers. Please provide feedback. That's it. Thank you again, Yuvaraj, for the demo.
And one final note to close it out. This command can actually be used even if you don't have a management cluster. So you can just pass in the file with the class, with the cluster, and it'll just work, right? You don't even need a acting management cluster to back it up. So that's even easier for someone to just start and try and see how cluster class operates.
Great stuff. Can you give me back host? I think I can't claim it because you already have it.
How do I make you?
On the participant list, right?
Changes.
Yeah, perfect. Looks good. Thanks. Okay, so next, Daniel.
Thanks. Yeah, I just wanted to bring up this this issue. Just filed it, I think, yesterday. It's kind of want to get feedback. So the issue is that you know, today it's possible, like, to have a machine deployment that is updated to a version that is ahead of the control plane, and for the, you know, for all the controllers to begin reconciling that, and for the infrastructure machine to be created, and for the bootstrap to be initiated, and for, you know, for that to eventually fail because the kubelet, well, it's not guaranteed, but you know, in case of like 121 versus 122, if you've got a 122 kubelet connecting to a 121 API server, it won't be able to register. It will fail, you know, trying to use certain APIs that I think have been removed. Any case, it's possible to violate the version skew policy, the Kubernetes version skew policy, and that seems like I guess what you might call a foot gun, right? It's a way for the user to you know, to inadvertently you know, make a change that to the cluster that doesn't you know, they can't possibly work. And yeah, I'm just interested in you know, if others see this as a problem. I've got a PR you know, showing one way that we could address this. But yeah, just wanted to get this on the radar. Thanks.
Yep, thank you. Any opinions? Fabrizio.
Yeah, thanks for reporting this in detail. I have to catch up with this stuff because I was busy with patch release, but yeah, we discovered something similar while starting with cluster class. Cluster class is the first point where we have, let me say, overall view of the version of the entire cluster. And we discovered that this, I was searching for the issue, but I needed a little more time. So we find out this, basically there is this possibility that you highlighted. It is also even more subtle, so you can basically try to change the version of your control plane, if I remember well. So yeah, we discussed how to get this fixed. I think I'm really interested in looking at your PR, because from the initial discussion that we had, which was really, let me say, high level, it was like cluster class was the only point where we can get let me say this entire view of the cluster, and also we were discussing about the idea of surfacing current Kubernetes version on or at least for the control plane on cluster level. So you can take, let me say, informed decision about which version to allow, stuff like that. So I'm aware of this problem. I don't have a solution yet, but thank you for bringing this to the attention and try to make it is getting a formal shape.
Yeah, I agree. I mean, on a cluster class level, we can avoid the problem, but I think it's on a high level, it makes absolute sense to also address this in the base controllers. I think the main issue we had at that point was like, yeah, how do we bubble up the information so that we can consume it in the right parts without, I don't know, making dependencies from the bootstrap provider to the control plane provider or some strange things like that. But I also have to take a look at the PR first.
In the PR actually ended up using the contract package, which came out of the cluster class work, and then I guess it moved out of the topology package. But that made the PR, you know, much smaller than I think it otherwise would have been.
Perfect. Okay, so yeah, I think we take a look soon. Any other concerns, questions? Otherwise, I think that was the last topic. Oh no, there's a new one. Yassine.
Yeah, I added the last one. So so in some of the providers, I actually started looking at the way kubelet talks to the API server, and it seems like in our CP kubelets in the control plane, we're using the control plane endpoint to reach out to the API server. This can have like some weird drawbacks when, for example, you're rolling out a new Kubernetes version, a new machine pops out with a new kubelet version, say 123, and it needs to talk back to the API server, and it can talk to pretty much any API server. It might be the 123 one, it might be the 122 one. So this has like that's basically the major drawback. The second one is in some of the providers, when you're using private clusters, so front-end things within internal load balancers, you might be facing a hairpin issue where the backend that is part of the load balancer might not be even able to talk to the load balancer. So I think that it's at least true for Azure and AWS. It might be also true for CapG, but I need to double check that. So I don't know if folks have considered that and if they have thoughts around it.
Yeah, Fabrizio.
So I'm trying to remember. So I remember that we discussed and we also made a change in Kubernetes not so long time ago in order to make sure that the current configuration on how Kubernetes talks cannot create version skew. That was the problem that we were talking about. So currently there are differences between worker nodes and control plane nodes, and those differences are meant were introduced to basically fix a problem when API version, when new Kube API version deprecate some API, and so we fixed this. If you have more detail about the problem that you are like, you are highlighting. I would like to take a look, but yeah, we already hit some problem in that area, and it's kind of critical to get the right session. So looking forward to understand what's not working.
Yeah, I'm currently working on a document to compile this. Hopefully for the next office hours, I should be able to share it.
Perfect. Okay. Any other opinions, other points? Otherwise, you're done. Okay. So have a nice day, week, everyone. A lot of fun with the new release, hopefully. See you next week.
Bye.